Hi, this is Alex from devstories.eu. LlamaIndex Context-Augmented LLM Applications, Episode 4 of 14. You're building an agent that fields IT support tickets, but half the submissions are just smartphone photos of flashing error lights. Text-only processing forces you to build separate vision pipelines or drop the visual context entirely. Today, we are covering interfacing with LLMs and multimodal inputs, which solves this right at the model layer. In LlamaIndex, interacting with a language model goes through the base LLM class. This acts as a unified interface. Whether you are calling an OpenAI model, an Anthropic model, or a different provider, the core methods you use are identical. This abstraction protects your application logic from provider-specific API changes. When you want an answer from the model, you choose between two primary methods. The first is the complete method. You pass it a single text string containing your prompt, and it returns a single text response. This is built for straightforward single-shot tasks like summarizing a document or extracting a specific fact. The second method is the chat method. This is designed for conversations or structured interactions. Instead of a single string, you pass a list of chat message objects. Each message has a specific role attached to it, typically system, user, or assistant. By passing a list, the chat method gives the model the full context of a back-and-forth exchange before generating its next reply. Both complete and chat wait for the model to finish its entire generation before returning the output. If the model's writing a long response, your application sits idle. To fix this, you use streaming. You call stream complete or stream chat instead. These methods return a generator. As the model produces tokens, your code receives them in small chunks. You loop through this generator to print the response to a user interface in real time, removing the perception of latency. Now, the second piece of this is handling non-text data. This is where it gets interesting. Modern LLMs parse visual information, and LlamaIndex supports this through content blocks. Instead of passing a simple text string inside a user chat message, you can pass a list of blocks. Think back to the IT support ticket with the broken server rack. You need the model to look at the photo and read your diagnostic instructions. First, you create an image block. You provide this block with the image data. LlamaIndex allows you to pass a local file path, a direct URL, or raw base64 encoded bytes. Next, you create a text block. You give it your text prompt, asking the model to identify the hardware fault shown in the picture. You put both the image block and the text block into a single list, and you attach that list to a new user chat message. When you pass this message into the chat method of a vision-capable model, the LLM processes the visual layout of the server rack alongside your text instructions. It returns a diagnosis based on both inputs combined. Here's the key insight. The real power of this architecture is its consistency. Whether you are sending a one-line string, streaming a real-time response, or passing a complex array of text and image blocks, the interaction pattern with the LLM class remains completely standardized across your entire code base. That's your lot for this one. Catch you next time.